Hello viewers, Wagadaruna taking you through the story of A-level pure mathematics. And this video we're going to go through the marking guide for Senior 5 Math 1 end of term 3 for the year 2023. So this video is suitable for students in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. So before we proceed, I would like to make you know these books which are very useful for your level. So in math, there are 4 books: Math 1, Math 2, Termly Pass, and a topical question bank. Same applies to physics. There are 4 books: Physics 1, Physics 2, topical question bank, and its solutions. So if you need any of these copies, contact me on this phone number. So some of you just go to bookshops and they charge you highly, then you go away regretting. So it's better you call so that I can direct you where you can easily get them at a cheaper price. So shall start with section A, question 1. It says, solve the equation this, giving your answer to 3 decimal places. So this came from indices. The first thing to do is to change this base, because this is base 2 and this base is 4. So if 4 is 2 to power 2, that's why you see here 2 to power 2. It is okay to interchange the powers. So after having that, I can now let y to be equal to 2 to power x. Then I substitute for 2 to power x, here to be y squared, here to be y. So now I have a quadratic equation which I can solve by factorization or bulldozer. So using the quadratic formula, I'll come up with this. So then I use a calculator to simplify and get the 2 values of y. So if you see these decimals, it means that a student who chose to use factorization could not get the factors. So the only option was to use the quadratic formula. But this is not the final answer, because the question was asking for x. So after getting the values of y, I remember that y is equal to 2 to power x. So I'll come and say that for y equal to this, then 2 to power x will be that. Now because these are decimals, the only option was to use logarithms, either log base 10 or natural logarithm. But for now you are not common that with lean, so we shall go to log base 10. So put log base 10 on both sides, you will come up with the value of x being equal to log of this divided by log of this, which gives you the answer to 3 decimal places. What about y equal to a negative? So when you put a log, it means y is x is undefined. And that's how the marks would be awarded. So now we shall go to question 2. Question 2 says, express this in the form of this. So this came from trigonometry under the section of our formula. First was to make this equivalent to this. I think you see the sign, it is equivalent. Then you expand this using compound angle identities. So r is constant, then sine theta plus alpha is equal to sine theta cos alpha plus cos theta sine alpha. Then this r multiplies this here and here. Then from there, because of this equivalent sign, you can compare. So comparing means if this is sine theta and this is sine theta, then the balance here is 2, the balance here is r cos alpha, meaning that r cos alpha is 2. Then here also cos theta, the balance here is 3, and here it is r sine alpha. So r sine alpha will be equal to 3. Now I can divide the two equations, this divide by this, you come up with this, whereby r can cancel and sine over cos gives you tan. 3 over 2 is 1.5. Then you can get the acute angle alpha. There we only need one angle, 56.31 degrees. Then I can use Pythagoras to come up with the value of r. This squared plus this squared, everything under square root to give you root 13. So here you don't again, because square root of 13 is not exact, therefore you just leave it as a square root 13. Don't write it in decimals. Then you can now write this in the form this, which came from here, where you substitute for r and for alpha. So basically that is what they wanted. And that's how marks would be awarded. Then question 3 was from, if you see this, maximum standard turning point, application of differentiation. So the curve y equal to this has a maximum point at this and passes through the point this. Find the values of a, b, c. So that's a given curve, and at point 218, x is 2, y is 18, so substitute for x and for y. You will come up with equation 1. But they also told us, okay, at point this, it passes through this point, so x is 0, y is 10. So substitute for y and for x. You will come up with the value of c. Then at the maximum point, dy dx is 0. So first come and differentiate and equate to 0. But they told us x is 2 and y is 18 at that point. So substitute for x, you will come up with a second equation. So we have this, we have this, we have this. We can use them to get the values of b and c. So what I'm going to do, here I have 4a, and also here I have 4a, so I'll come and substitute for 4a and for c in equation 1. So where there was 4a, I'll put the negative b, which is this, and where there was c, I'll put the value of c, which is this. Now I have only one unknown, which is b. So simplify, you'll come up with b as 8. After getting b, I can come here and get the value of a. So 4a is equal to negative 18, implying that a is negative 2. And basically, that is what they wanted. Then question 3 came from further topics in trigonometry under the section of angles of a triangle. So it says, show that in a triangle ABC, tan A plus tan B plus tan C is equal to tan A, tan B, tan C, everything multiplied. So shall I begin by saying that for angles of a triangle, A plus B is equal to 180 minus C, then you put tan on both sides to come up with tan A plus B equal to tan 180 minus C. Then you expand both sides. This one gives you tan A plus tan B over 1 minus tan A tan C, sorry, tan B. Then this one will be in the second quadrant, and in the second quadrant, tan is negative, so it becomes negative tan C. Then we can cross multiply. Take this on this side to come up with this step, open brackets to come up with this step. Then this is negative, it goes this side to come up with the required proof. And that's what they wanted. Then question 5, find the equation of the circle that is under geometry. Equation of the circle whose center is the point this, and it touches the line this at only one point. So this line has a positive gradient. So I'll come and make a sketch of a circle with the center 3, 3. And the straight line with a positive gradient. And it is at only one point, meaning it's a tangent. Let that point be P. So the distance from C to P will be the radius. And because it's a tangent to the angle, will be 90. So they have told us to find the equation of the circle. The good thing I know the center. What I don't know is the radius. So I'm going to first get the radius, which is the distance of this point from this line. The good thing that formula is also there in your logbooks. So I'll come and substitute 6 times x is 3, minus 4, which is here, times y is 3, plus 7, over the square root of the squares of the coefficients. So coefficient of x is 6, so which is 6 squared, and yet is negative 4. You square it becomes 4 squared. Everything under square root. So that formula is available in your logbooks. So simplify and come up with the radius. So now that I have radius and I have the center, I can quote the general formula of a circle, general equation of a circle. And next will be simplifying, expand and collect like terms. Expand. So here I've cross multiplied, taking this for this side to come up with this. Open brackets and collect like terms. Take this on here. That will be the equation of the circle. And that's what they wanted. Then question 6, solve the inequality list. So that is under algebra. So yeah, the good thing, they have already broken it down in 2 factors. So your work is to state the critical values. Critical values are got by equating each factor to 0, each bracket to 0. So equate this to 0, I'll come up with x equal to negative 1. Equate this to 0, I'll come up with x equal to 2. Equate this to 0, I'll come up with x equal to 3.5. So I think they are arranged in ascending order. Then from there, I can now tabulate. Tabulating, I'll need these terms still in ascending order. It's better if they are done in ascending order. So begin with that, followed by this, and followed by this. But if you interchange the order, it is okay. Then you write the whole of this here. Then you start. For values of x less than this first value, what will happen? So less than that means I can use negative 2. Put negative 2 here, you'll come up with a negative. Put negative 2 here, come up with a negative. Put negative 2 here, you'll come up with a positive. So this gives a positive, positive, the end result is a positive. Then what about values of x between this and this? There I can choose 0. So put 0 here, it's positive, 0 here, negative, 0 here, positive. So this gives a negative and a positive, which is a negative. Then what about values of x between this and this? I can choose 3. So put 3 here, it's positive, 3 here, positive, 3 here, positive. So everything will become positive. Then what about values of x after this? We can choose 4. So put 4 here, positive, 4 here, positive, 4 here, negative, and everything will now be negative. Then from there, you come up with, you look at this. Greater than 0 means they want positive values. So this is needed. and this is needed. We shall remove this and remove this. Therefore, we can conclude the solution set is x less than -1 and x is greater than 2 but less than 3.5. You should realize we are not putting there the or equal to. Why? Because the question did not have it. Here, if there was or equal to here, we would also have put or equal to here, but not in the table. So 1 mark was for each column correct, this correct, B1, this correct, B1, this correct, and this correct. Then this last one also stating both. That was question 6. Now question 7. If a line y equal to mx plus c is the tangent to the curve this, show that the c squared is equal to 4 plus 3m squared. So I'll come and quote the equation of the curve and substitute the value and substitute for y here. Then open brackets. First of all, this inner bracket, expand this to give you this. Then open the entire bracket. Then you have to collect like terms, x squared alone, x alone, and constants alone, which gives you that. Then from there, you remember the condition for tangency that has repeated roots, therefore b squared minus 4ac is equal to 0. So b is this 6mc, a is this, and c is that. So come and substitute b squared 4 times ac. Then next is to simplify until we get this. So first what we did, we open brackets. So this times this is 12, which is here. Then this bracket times this bracket, you come up with this. So how does it come about? It will be 4 times c squared, which is this. Then 4 times -4, which is -16. Then 3m squared times c squared, which is this. 3m squared times -4, which is that. Then the whole of this is squared to give you this. So you can reduce, divide throughout by 12. This becomes 3 and this is 1. That's why you see here 3 and 1 here. Then from there, this can cancel with this to remain with -4c squared. Then negative and negative is positive. Then negative and negative is positive. Then you reduce, okay, rearrange and you reduce because here they want c squared, so divide throughout by 4 to give you what they wanted. So that's how we could get the 5 marks. Then question 8 came from the topic of further topics in trigonometry under the section of inverse trigonometry and says, show that this is equal to that. So the first thing to do is to remove the inverse by let alpha be this and beta be this. That means that tan alpha is a half, tan beta is 1/5. So this is this plus this, so it will become alpha plus beta. So but tan, when you put tan, you'll come up with tan alpha plus beta being equal to this. When you expand, the good thing, this identity is there in your logbooks. Then you shall come and substitute for tan alpha and tan beta. Tan alpha, tan beta. The numerator gives 7/10, denominator gives 9/10, everything gives 7/9. Then put tan on the other side to become alpha plus beta is equal to arctan 7/9. But remember that alpha is this and beta is this. So substitute, you'll be able to get the required proof. So that's how we could get the 5 marks. That was section A. Now we shall go to section B. So section B, question 9 says, part A, differentiate this with respect to x. So this is now a quotient. We expect you to recall the quotient formula. So differentiate this, you use quotient formula where you keep this one constant, then differentiate this, which gives you 2x. Okay, then minus, keep the numerator constant, differentiate the denominator. Then everything divided by square of the denominator. Then rest that there you have differentiated. Next is to simplify. So rearranging this gives this. Then you realize that there is a common factor here. Factorize it out. X plus 1 squared. Here remain with 2x. And also 1x plus 1 because this was chopped, and here I've removed the square. So remain with 1x plus 1. Then here I remain with 3 and this because the whole of this has gone out. Then you realize that this and this are the same base, so you can take this down to become x power 4. Then here I open brackets to come up with this, collect like terms. Then you realize that you can't factorize it, so you stop there. So that's how we could get the 4 marks. Then part B, given that x is this and y is this, find the second derivative in terms of t in the simplest form. So first of all, x is this, which is a quotient. So I use quotient formula to get the derivative. So first is to keep the denominator constant and differentiate the numerator, which is that, minus, keep the numerator constant, differentiate the denominator, give that. Then divide by the square of the denominator. So there you have differentiated. Next is to simplify. So open this bracket, 3 times this is 3t, 3 times this is 9, then minus 3t over that. So this and this cancels, remain with 9 alone and this in the denominator. So that is dx dt. What about dy dt? So still quotient formula, keep the denominator constant, differentiate the numerator, minus, keep the numerator constant, differentiate the denominator, over the square of the denominator. Then simplify to come up with that. Then I can use chain rule to get dy dx. dy dx is equal to dy dt times dt dx. So dy dt, then dt dx will be the reciprocal. You end up with that. That was first derivative. What about second derivative? Second derivative, what you're going to do, you're going to first differentiate with respect to t. Then you can use the chain rule to get the 2y dx squared. So ddt of this first derivative is this. Note that I'm using d dt, not dx. So most students confuse it. So still this is the quotient. What I'm going to do, for me I chose to first put the negative outside. Then I put a very big bracket of differentiating only this positive part. So I'll still use quotient formula, keep this constant, then differentiate the numerator, minus, keep the numerator constant, differentiate the denominator, over the square of the denominator. So differentiated, next is to simplify. To simplify from this to this, okay, here I've just rewritten this, but change the order. So I began with a constant, followed by this, followed by this, then constant, followed by this, followed by this, only that. But from here to here, I did something funny. Do you see this? There's a negative here, so it went inside to change. So this became negative and this became positive. That's why you see here positive and this. So they have changed because this is negative now, this is positive. So this negative is here and this now, which is now positive, is there. But why is the t minus 2 not there here? It is because here there is t minus 2, okay. Here there is also t minus 2. So t minus 2 is common and can be factorized out to reduce this power by 1. That's why here you see t to power 3. So 1 t minus 2 went to remain with 2 t minus 2 t plus 3, which is here. Then here this t minus 2 went to remain with 2 t plus 3 squared. So before we go to the next slide, those are the marks for this slide. So factorize out also t plus 3 and 2 to come up with this. Where when you open this bracket, you come up with this t will cancel. This is 5. 5 times 2 is 10. Then there is also t plus 3 and the denominator is there. But remember that is d dt, but the question wanted d2y dx squared. So we have to use chain rule, d dt times dt dx. d dt is that of the first derivative times the t dx. You come up with this, which is that. And that's what they wanted. Then question 10, part A says, is from algebra, so it says solve the simultaneous equations, these ones. So from this, which is linear, I can make y the subject. Then I come and write this, which is non-linear, and substitute for y. Where there is y, I'll put there this, that, that. The next is to expand. So first here, this and this went, that's why you don't see here. Then this negative entered inside to become positive, positive. Negative, so okay, then this is what we did. This went with this, then negative x came inside to become positive x, then also negative x times this to become positive 3x squared. Okay, what about here? Now here, the whole of this is squared. When I square the numerator, I'll come up with this. Then denominator, I'll come up with 4. But there is a 2 here. So 2 divided by 4, you get a half. That's why you see here 2 only, not 4. Okay, then this one remains as it is. Then this one, the 5 went inside to come up with this. And this remains as it is. So before going to the next slide, that's the marks for this slide. Now from this step, you can choose to multiply throughout by 2 to remove this fraction. It is okay. Or you can choose to split the numerator. So 1 divided by 2 to get a half, 6 divided by 2 to get 3, 9 divided by 2 to get 4.5. Then here, negative 5 divided by 2 to get negative 2.5, negative 15 divided by 15x divided by 2 to get negative 7.5x. So any is okay. Let me choose that one of splitting the numerator. When I split the numerator, I'll come up with that. Then I can now collect the like terms to come up with this quadratic and solve it using the quadratic formula since they are decimals to come up with those values. So these ones are exact, meaning that even one who used factorization method will get the answers. But it's advisable to always use the quadratic formula because it works for all. So I've got the values of x. What about values of y? So when x is this, come and substitute for y, which is that. When x is this, substitute for y to get that. And that's what they wanted. So that was part A. Part B says if log base 4 of m is equal to a and log base 12 of m is equal to b, prove that log base 3 of m is equal to ab over a minus b. So there are two approaches. One is to start from the right hand side. When I start from the right hand side, I'll substitute for a, for b, a, b. Then I remember that the required proof is in base 3, so I'll convert everything to base 3. So this to base 3 gives that, this to base 3, this to base 3, and this to base 3. Then from there, I'll get LCM for each numerator and denominator. For numerator, this times this gives that, and this times this gives this. For denominator, this is common, so I'll pull it out. Then in brackets, I'll get LCM of this and this is here. So the whole of this divided by this, you remain with log base 3 of 12, which is here. Then the whole of this divided by this, you remain with log base 3 of 4, which is here. The minus comes from here. So realize that this is the same as this. So it can cancel. Then you also realize that this can also reduce this power. So remain with that. Then from there, this is same base, so subtraction, I can divide the 2. So 12 over 4 gives you 3, which is here. Then log base 3 of 3 gives 1, so I remain with what they wanted. So that is one way of attempting that. What if you use the method of indices by first eliminating the log and then you bring it back again? So you can say from this it implies that 4 to power a is equal to m. Then I make 4 the subject by multiplying by everything raised to the power 1 over a on both sides to give you this. Then also log base 12 of m is equal to b. 12 to power b is equal to m, which is there. Then you realize that this becomes that from the laws of indices. Now I'm going to divide the 2. When I divide the 2, I'll come up with this. This is same base, I can subtract the powers, and this gives you 3. So get the LCM of this power, you'll come up with this. Then you put log base 3 on both sides, log base 3, log base 3. This becomes 1, which is here. And this power can go down, which is here. Then I'll make this the subject to come up with this, which they wanted. So that's the other alternative. So now shall go to question 11, which came from trigonometry. So part A says show that tan 3 theta is equal to this. So first of all, 3 theta is the same as 2 theta plus theta. When I use compound angle, I'll come up with this. Then when I use double angle identity, all these identities are there in the logbook. So the double angle identity, the whole of this becomes this, and also this becomes that. Then I'll get the LCM in the numerator. LCM is this. So here I remain with this, and here I remain with, I'll come up with this times the LCM, which is that. That is for the numerator. For the denominator, it's still the same. LCM is this. Then here it will be this times the denominator times the LCM minus 2 tan squared because of this tan times tan. So realize that this is similar to this, so they can cancel, and you remain with this is as the numerator and this as the denominator. But they are simplified. If you look at this, this one is 2 tan theta plus tan theta minus tan cubed theta. So 2 tan theta plus tan theta gives you 3 tan theta minus tan cubed theta. So applies to this. For this one, it is 1, then minus tan squared theta minus 2 tan squared theta, which gives you minus 3 tan squared theta. In the numerator, tan theta is common, so factorize it out, you will come up with the required proof. And that's what they wanted. Alternatively, you could first change this in terms of sine and cos. It also works. So sine over sine, expand this, you will come up with that. Then you realize that here sine theta is common, pull it out. Here cos theta is common, pull it out. So this over this gives you tan. Then this remains and this remains. Then from there, to bring in the tan, I'll have to multiply both up and down by 1 over cos squared theta. So when I do that, I'll come up with this 3 times this gives you sec, and this times this gives you tan. So here this and this cancels, and this with this gives you sec. But I know that sec squared theta is 1 plus tan squared theta. It's also an identity in the logbook. So substitute for sec squared theta and simplify. You'll come up with that. So that was another alternative. And now we shall go to part B, which says solve the equation this. So the good thing, all of them have cos, meaning you can use factor formula. Now I'll pair I'll pair them in such a way that I get an angle similar to the other ratio. For example, if you look at this, this plus this is 8 divided by 2 is 4, and 4 is here. That's what I meant. Because at the end of it all, you have to factorize. So when I pair this, cos plus cos gives me this. Then I have this and this, which is common. Then you factorize it out, meaning either cos this is 0 or this is 0. So for this one, the value angles of 4x will be this. Now remember, they give us a range. They said from 0 to 180. So what does that mean? It means that 4x will have to get angles until we get 4 times 180. So 4 times 180, it gives 720. So I don't exceed 720. Now, why did I stop there and how did I get them? One, Cost 0 is, when you press calculator, cost 0 is 90. Then also we have this, and we also have that, which is 270. Then the rest will be got by adding 360 to each. So 360 plus 90 gives you 450. Then 360 plus 270 gives this. Now if I say 360 plus 450, it will be beyond 720. That is why I stop at 360. Then I can get the values of x by dividing throughout by 4. What about for this? For this one, still do the same. Cost is negative in the second and third quadrants. So I'll get these angles, divide by 2 throughout to get this. Then you can arrange in ascending order. And that's what they wanted. Question 12. Question 12 is from application of differentiation. Part A says using calculus or small changes, show that this is equal to this. So let's begin with that. First of all, realize that 10 cubed is 1000 and 11 cubed is this, meaning that this one is closer to this. That's why we are using 1000 plus 5. Therefore, y plus small change in y approximates to cube root of x plus small change in x. And by comparison, it means x is 1000 and small change in x is 5. That means that y is cube root of x, which is 10 when you substitute for x. Then differentiate this to come up with this, then substitute for x to come up with that. Therefore, you can use that small change in y approximates to dy dx times small change in x, substitute for dy dx and also for small change in x to come up with 1/60. So now I have the value of y and also the value of small change in y, meaning I can get the required cube root. Therefore, I come here and say that the required cube root is equal to y plus small change in y. Y is here, small change in y is here, which gives you that. And that's what they wanted. Then for part B says a ship cruising at a constant speed of this has a distance of this to travel. Given that the cost C of the journey is a function of this per hour. Roman 1, write down an expression for the total cost of the journey. And Roman 2, determine the speed that minimizes the cost of the journey in A above and hence the minimum cost. So first of all, realize that this is per hour and we know speed, we know distance, meaning I can get time. So time is distance over speed. And then that will be time, then this, because this is per hour, I multiply this times the time to get the total cost. So the total cost will be cost per hour times time. Cost per hour is this, time is this, open brackets, come up with that. Roman 2, I can now differentiate. When I differentiate this, I'll come up with this. Then equate to 0 for minimum cost. Then simplify to get the value of x. So cross multiply, divide through by 200 and get the cube root of that, which is 20. Meaning that the minimum speed will be that. Then for the hence part, the minimum cost, come back to this value of y. and substitute for x. Use a calculator and that will be the answer they wanted. Then question 13, part A says, the sum of the first 5 terms of an arithmetic progression is this. If 5 times the 7th term is the same as 6 times the second term, find the first term and common difference. So sum is that. Sum of an AP, substitute for n, which is that, and equate it to this. So that will be equation 1. Then equation 2, they said 5 times the 7th term, that is t7. 5t7 is the same as 6 times the second term, that is t2, 6 times t2. So they are equal. So I'll come and substitute. 7th term is here, second term is here. Expand and get correct items to get equation 2. So I have 2 equations, 2 unknowns I can solve simultaneously. Substituting equation 2 into 1, I'll come up with that. Simplify to get the value of d. Then from equation, this will be equation 2. From equation 2, A is that. That was part A. Then part B, if fx is this, has factors this and this, find the values of p and q and hence obtain the remaining factors. Factors means the remainder is 0. So when x is -1, come and substitute for x and simplify to get an equation. So these are the marks for this slide. Then go the next factor. When x is -2, substitute for x and simplify to get an equation. Those are 2 equations, 2 unknowns that can be solved simultaneously. So when I subtract, I'll come up with p equal to -5. Then from equation 1, I can get the value of q as 2. So for the hence part, we can now rewrite the function with no unknown. They want us to get the other factors, meaning I need a divisor. The divisor will be this, expand to get this. Then I can use either long division or synthetic approach. But before that, let's see the marks for this slide. So we shall look at both approaches. Let's start with long division. For long division, I'll put the divisor here and the function here, or the polynomial. Then I'll start dividing. We divide the highest powers. So this divide by this, you come up with 3x squared and you put it here. Then next, this one multiply throughout by this, you'll come up with this. After that, you subtract the 2. You'll come up this minus that cancels this with this. Is that this with this, and this you subtract nothing, you come up with that. Then still repeat the procedure. This divide by this, -4x. Then -4x multiplied throughout by this, you'll come up with that. Then you subtract the 2. You'll come up with this. Then still do the same. This divided by this. Then 1 throughout this, you come up with this. Then you subtract the 2. There will be 0 because this is 0, 0, 0. So there is no remainder. So do you know what that means? Okay, let's use that. That was long division. Another one can use synthetic approach. Synthetic, you write the coefficients of all these ones in order. So this will be coefficient of x power 4, coefficient of x power 5, x power 3, coefficient of x squared, coefficient of x, and a constant. Then, now here you don't use quadratic. You'll go back here and remember that we had x equal to -1 and also x equal to -2. So whatever you start with is okay. So let's start with x equal to -1. So what you do, you bring this 3 down here. Then 3 times -1 gives you -3. That's what you put here. Then you add these 2 to get 2. Then 2 times -1 is what you put here. Then add these 2 to get -7. -7 times -1 is what you put here. Then add these 2 to get +2. +2 times -1 is what you put here. Then add these 2 to get 0. So this is what they call remainder. So when there is a 0, it means remainder is 0. That was for the first factor. What about for the second factor? For the second factor, now we shall get this one. And then use the second factor. So still do the same. This, bring it here. Then 3 times -2, -6. Add the 2 to get -4. -4 times -2. Then you add these ones to get 1. 1 times -2. Then add these ones to get 0. So 0 means there's no remainder. Now, this is the same as this. If you realize, because remember, synthetic, we deal with only coefficients. So if you look at this, it is here. If you look at this -4, it is here. If you look at this one, it is here. So any of the 2 approaches is okay. That means that fx is equal to these 2 factors followed by this quotient. Now I have to factorize this, where the sum is -4 and product is 3. They'll split the middle term to give you this. Then I pair, this gives you this, and this gives you this. Then I can write the factors they wanted. And that's what they wanted. So if you used synthetic method, there was no need to expand this divisor. That is why for long division, there is only 1 mark. If you look at this, there's only 1 mark because the second mark went at expanding the divisor. But for synthetic, there's no need to expand. That's why there are 2 marks there. Then question 14, part A says, find the acute angle between the lines this, and the coordinates of the point where they intersect. So angle between 2 lines, we need their gradients. For this, the gradient is that, and here the gradient is that. Then from there, you can use the formula which is there in your logbook. Angle between two lines given by that with a magnitude sign there. So that if you get a negative, it changes into a positive. Then you can substitute for M1, for M2, M1, M2. So you come up with this, and the angle will be that. So equation 1 plus equation 2, we shall get this, where the value of y is that. Then from equation 1, I can get the value of x, which should be that. Therefore, the point of intersection is this. That was part A. Then part B, they said, the line joining the points this and this is perpendicular to the line this, and they intersect at N. Given that N is the midpoint of PQ, find the values of alpha and beta. So we have that line, it has a negative gradient, it's perpendicular to the line joining points P and Q, and N is the midpoint. So for this line, gradient is that, and so perpendicular lines, for perpendicular lines, the product of the gradients is -1. So gradient of line PQ is this. So substitute for the gradient of PQ. Then you simplify to get an equation in terms of alpha and beta. That is one. Then also told us that N is the midpoint. So midpoint of these two is the average of their coordinates. And that point lies on this line. So I'll substitute for x and y. And get an equation also in terms of alpha and beta. So now I have two equations and two unknowns, meaning I have to solve them simultaneously. So equation 1 times 3 plus equation 2 times 4 gives you this, therefore alpha is that. And from equation 1, substitute for alpha and get the value of beta. And that's what they wanted. Then question 15, part A says, sketch the curve this. So first is to expand, then you differentiate and equate to 0 to get the turning points. So value of x is 1. Then when x is 1, get the corresponding value of y from here. Therefore, the turning point is that. What about the nature? For the nature, you differentiate the second time, meaning that the point is maximum. Why? Because the second derivative is smaller than 0. Okay, so now we have got the turning point and the nature. What about the intercepts? So when x is 0, y is 0. When y is 0, x will be this or this, meaning that the intercepts are this and that. So now we can sketch. We shall draw the axes and show the intercepts and also the turning point. So it's a maximum, therefore we shall draw the shape in that form and label the curve, and that's what they wanted. Then part B says the area bounded by the curve and the x-axis is rotated about the x-axis through half revolution. Determine the volume of the solid generated. They said half. So usually we are used to complete revolution, but this time they said half, meaning I expected to see this a half. Then you substitute for y, expand, then you can expand fully, then you can integrate. Then substitute limits, then use the calculator to get the output, and that's what they wanted. So that's how marks would be awarded. Then question 16, part A says, prove by induction that this is equal to that, where n is a whole number. So the first thing to do is to generate the series. When I put 1 here, I'll come up with this. Put 2, I'll come up with this. Put n, I'll come up with this. Everything will be equal to that. Then start testing for n equal to 1. Left hand side will be this, which is 1. And right hand side, 1 times 2 times 3, which is 6 over 6, which is 1. Therefore, it is true for n equal to 1. What about n equal to 2? The first two terms here are these, which is 5. Then for the right hand side, 2 times 3 times 5 over 6. This is 30 divided by 6 is 5. So it is true because left hand side is equal to right hand side. Then next will be the assumption. Suppose it's true for n equal to k, then the series becomes that, where there is n you put k. Each time there was n you put k. Then for n equal to k plus 1, it means that where there was, here we have to prove. Here it was suppose, that's what we just wrote. But here we don't just write. We have to show that left hand side is equal to right hand side. So right hand side is got by substituting. So just substitute where there was n, you put k plus 1, k plus 1, k plus 1 to come up with that. And I can choose to expand this to brackets to come up with this, which is that. Then left hand side, it means on this n equal to k terms, you add their one next term. And we saw that from the assumption that this here is equal to the whole of this. So I'll come and substitute it here. Then I'll get LCM, which is 6, to give you this in the numerator. If you look at the numerator, k plus 1 is common. So I'll pull it out. I'll remain with k, then 2k plus 1. Here I remain with 6 and 1k plus 1. So if you compare, I have this here. Okay, I have this. Okay, let's use this. I have this. I have this here, and I have this here. So this bracket, so my aim is to expand this bracket and see if it is similar to this. So let me do that. Expand this to give you this, collect like terms to give you that. If you realize the whole of this is the same as this, so they have shown that left hand side is equal to right hand side. Then you can conclude. And that's what they wanted. Then for part B, said from the result in A above, deduce that this is equal to this. So there, some of you are still trying to prove by induction, but they only wanted you to deduce. So 1, before this term, there is 1 plus 2 squared. The whole of this is there before that. So what do we do? What did they want you to do? They only wanted you to subtract. They wanted you to say this minus that. Why? Because this one starts from 1 up to n plus 1, and this one starts from 1 up to n. So if they want from n plus 1, it means that you have to remove the whole of 1 up to n. That's why we subtract it off. So how do you get this expression? You still come back to the given expression of this one, if you look at this. But this time around, where there is n, you put there 2n plus 2. So this replaced with 2n plus 2, this 2n plus 2, this 2n plus 2. That's the only difference. Simplify to get that. Then start factorizing. This one is common, and also this one is common. So I'll pull them out. Here I remain with 2. This 2 went here to become 4n plus 6, and that. Here, this went, so I have this n which came here to get to become n in brackets 2n plus 1. Expand the box bracket. The whole of this expands to give you this. Then this expands to give you this. Then we collect like terms to get that. So this is a quadratic. We have to factorize up. We have to factorize it. So the factors are these ones. Therefore, we shall group to get this and this. Then we factorize. And that's what they wanted. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on marking guide for math part 2 of end of term 3. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know any student who is not yet on this platform, please share the link of this video with them via